All right, so today in this session we will discuss about the object-oriented programming strategies and concepts, and this will be introduction to OOPS concepts, and using which we will proceed in our journey for learning Java programming language. All right, this will form the foundation for the whole concepts in Java. All right. And this understanding this is pretty important for you to understand how Java code is written. So the benefits of object-oriented programming concepts are, they are numerous. So because the first and foremost thing what you can think of is it gives you the easiness of programming. All right. So with object-oriented concepts, people can write better code which can be reusable, it can be modular, it can be flexible, and uh, so there are plenty of benefits for using object-oriented model in your application development. So Java follows this object-oriented programming concepts, and that makes Java one of the best languages or preferred languages across the developers community. So in today's session, we will try to understand what are the object-oriented concepts and how does Java implement these concepts. We will have a look at those topics in the subsequent sessions as and when we proceed towards the Java syntax and semantics and all those things. So we will continue understanding these object-oriented concepts, how they are implemented in Java. So the first and foremost thing what we will like to know in object-oriented programming concepts is about a class. So a class is a prototype or a blueprint for defining objects. Okay. So now what are objects? You might have a question. Obviously, objects are the real-world entities which are translated to programmable entities. So an object-oriented program in a program is generally split in form of objects. Just like in real world, you have plenty of objects around you, and any anything what you use in your day-to-day life is made of some objects. It is composed of different objects. For instance, if you look at your machine, if you look at your system itself, if you look at your computer, it is made up of multiple components, multiple objects. A keyboard, a hard disk, a RAM, and a computer monitor, screen, and mouse, and trackboard, blah blah blah. So these are different objects which are composition and making it as one big system, one big application. So in programming world as well, we use this concept of object oriented nature, and we create applications. We create big, large enterprise applications, and we segregate the functionalities of that application in form of objects. All right. So if you want to maybe imagine that you want to create an application for maybe a hospital management system. So in your hospital management system, you will have different type of entities used in your whole application. You might have something called a patient, you might have something called as a doctor, and you might have medicines, you might have bills, you might have blah blah. There might be numerous things. So this is where you have to identify what are the objects of your system, and based on the objects in your system you will categorize those objects and define them using a class. So to come up with a class, to actually create an object, you first need to have a class. You have to define a class, you have to define how the object should be. So what is a class? It is just like a prototype which defines what the objects should be. It's like a blueprint. Imagine that you are about to build a house, a building. All right. So if you want to build a building, you will not start directly getting concrete and sand and bricks and start building it. Okay, you will not do it right from the day one. So what you will do initially? So initially you will go to an architect and get for a sketch. you will get a sketch, and you will design how your house should be, what I mean, how many rooms are you want, how many floors you want, and how many doors you have to allocate, and how many windows you have to assemble, and what should be the area of your construction, what should be the floor area, what should be the ground area. So all these minute details you design it on a paper. Okay, you design it on a paper, and then based on that design, you first get approved with your house members. Maybe you will see that this is how I will build a house, and this is what will go inside. And after the approval, then you start building the house. All right. So similarly, in case of object-oriented strategies or program concepts, you will have to have a blueprint of an object. The blueprint is in form of a class. All right. So if you remember that when we have done uh, application programming yesterday, we have written some class. Similarly, in case of this as well, we will write from we'll create class. Let's imagine that I want to create a person object. Person. So before I create the person object, I have to define what the person should be. All right. So that definition I do by writing a class. Then what is an object? Object is, you can simply say object is an instance of a class, because you have defined already a class, and when you instantiate it, when you make an object, that is when it becomes an object. All right. So it's a real world entity, or it's a programmable entity which has its own state and behavior. So we will come to this in few minutes as to why it has its own state and behavior. But you can understand an object by understanding that it is a programmable entity or a software bundle with related state and behavior. So every object will have its own state and behavior. What do I mean that? We'll understand in a few minutes. So let's understand that this is a class, and if I want to create an object of this class, I will instantiate it by using this approach: person p equals to new person. All right. I'm just writing it barely here. I'm not actually intending to do anything here. I just want to say that if you have to instantiate an object, you do this. You are creating an object. Class, or you can say initializing a class, you create an object. All right. Method is again the ability of an object to do something, because you want to create objects which are doing something. Okay, you intend to do something. These are the functionalities of your program. So the functionality is implemented in form of methods. So let's imagine that my class person has the person now needs to talk. So I want to define this talk as a method. All right, this talk is a method for me. It is the functionality which makes the person talk. All right, and this is the body of talk. Maybe it is how things person talks. All right, if you have an object is can have multiple functionalities. You can have more than one behavior, obviously. I can say walk. So any piece of functionality is implemented in form of methods. Any functionality what your class can do is implemented in form of method. All right. Method is also an ability to do something of an object, and methods also pass some messages which can be used for communicating between different objects as well. A method can pass on some messages to other objects that can be used for inter-object communication as well. All right. So these are the three basic constructs in your object-oriented programming concepts. First thing is a class, which is a blueprint, a prototype. Then the second thing is an object, and lastly, method. So when I say that a class is a blueprint, so I mean to say that I can define a class which can be used for creating multiple objects. So I can use the same class person p2 equals to new person. All right. So this is there are two different objects now. I have one object called p and another object called p1. Sorry about that. So that's what you can do. Okay. We'll go into more details about that in few minutes. Then the next thing, what object-oriented programming concepts say that these are the benefits what you get now. These are the pillars, you can say, or benefits in abstraction, encapsulation, inheritance, and polymorphism. So these are the direct benefits what you derive by using object-oriented strategies. What is abstraction? Abstraction means simply hiding the unnecessary details for the user. So a method might have some implementation, a method has some functionality, a method has some complex functionality here. It has maybe some complex functionality, but you don't expose or you don't let the end user know what functionality you are implementing. The end user is simply using the handle of the method, and method end user can call your method just by using the handle. I can say p1 dot walk. So when I say this, I can use the method without knowing what functionality it provides. All right. So this feature is called as abstraction. Abstraction serves a lot of important purpose in your application development by hiding unnecessary details for you. All right, and it actually becomes easy for you to start using an object without bothering what the implementation inside is. All right, then we have these benefits: encapsulation, inheritance, and polymorphism. We will visit them in few minutes from now. All right, but these are the benefits what you derive. Encapsulation means binding or wrapping the data and the method. You make the data bind to method. All right, and inheritance is actually reusing the properties of superclass or parent class. And lastly, polymorphism means you can have more than one form for your objects. All right, so we will visit these benefits in few minutes from now. All right, so benefits of object oriented programming concepts when you use OOPS in your application development. The applications are modular. When I say modular, it means that the applications are made of multiple modules, multiple components, and if you want to change any component, any module, you can simply remove that module and plug in the new module. So this actually provides a lot of benefits for us in real world, that the applications which sorry, so the enterprise applications what we have currently, they are not actually implemented by one single source, and the application can be implemented in a modular fashion, and it can be implemented by several parties. Several companies can get involved in creating an application. All right, so that feature actually is provided at the core of Java. All right, Java has modular support at the core. So imagine that if you are having an application now, an online shopping application, maybe let's assume. So you're not expected to build every piece of that online shopping application by yourself. All right, there might be plenty of modules which are available already, and you can simply plug them in your application and start using them. For instance, you are having a need for online payments in your online shopping application. So this online payments, you can use a external component. You can purchase a component which is already available and integrate with your application. You don't have to build it from the scratch. Let's assume you want to have a credit card validation. You have to validate every credit card for its authenticity. All right, now you don't have to build it from the scratch. You might simply take some service provider like eBay or PayPal or blah blah, and you can use their authentication services or validation services for your credit card and simply get the work done. So this feature is provided at the core of Java. Okay. And then benefits, other benefits is information hiding. You can actually hide the information from the end user. Hiding information means what? I mean, you are hiding the implementation of your data method. Sorry. So the methods what you write, you don't have to expose these methods to the end user. You can hide the, you can do the abstraction. Apart from that, you can do the data hiding as well. You want to hide some complex data. All right, you can hide them by using object-oriented features like encapsulation. Encapsulation is about hiding data. Okay, we will see that in a moment. So that is the other benefit. And then code reuse is one of the important benefits. You create one definition. You have one definition of a class, and you can instantiate a number of objects. So that is one of the code reuse features. And if you want to inherit something, or if you want to create objects of similar class but which has some different uh, behavior or some different method, so you can do the inheritance, and then you can override the functionality what you want. So all in all, you can have a good feature to go with code reuse in your application. And lastly, pluggability and debugging is, so with having this much of modular support, you can have pluggable applications. Plug application from one source and use it in your application and get done with the work. As well as debugging is made easy because of the inherent features of Java. All right. So let's see how to actually implement object-oriented programming features in our applications. All right, how to follow these things. So first thing we start is by understanding how to design a class. All right, classes play the important role of the application development, and that's where you will spend good amount of time to define how your object should be. So as I said earlier, that a class is a blueprint of your object, and it has minute details about what an object should be like. All right. So here in our application, let's take this person class itself. We will take this person class as an example and start writing this. So in my class, I have defined a class called person, in which I want to have functionality like talk. So I will go with void method because this doesn't return anything. So I will go for a void. This method doesn't return anything, and I'll have a print method here. Person talking, and person working. All right. So this is the functionality what I have defined for a class. The functionality is implemented in form of methods. All right. Then when I run this application, I will do that in another class just for the sake of convenience. I'll say person demo. I have a person. I'm creating one person object here, and I'm creating another person object here. I'm saying p dot talk. Let me save this with the name. Where by the way, my workspace. All right. Person demo dot java. All right, now this is just the method. Apart from that, your person or your class or your object in your program might want to have some data. All right, it might have some data, and the data is given in form of instance variables, or maybe the data means the state of the object. Okay, for instance, a person may have name, string name. Person may have an age, string name age, int age. All right, so I want to maybe use this data in my objects. Okay, so that's where we can actually use the instance variables. Now the reason why we call it as instance variable is the reason why we call it as instance variable is every object will have this data. Every object will have a name, every object will have an age in case of person object. So the reason of defining this in a class is that every object will have it. It is expected that every object should have this, so that's why we define it as part of the class definition. All right. Now every object can have, as I said, it can have name. So I can say p dot name equals to, all right, I can say fine, p1 dot name equals to, all right, let me actually run this now. So let me compile the class called person demo.java. It is compiled without any errors. Let me now execute it. There you see, it is showing person talking and person walking. All right, I haven't actually given any name here, so instead of saying person, I'll do one thing. I'll simply say name plus talking. All right, and here as well I'll say name plus. So name plus means it concatenates this string. This name is a string, right, and this talking is also a string, so it is concatenating these two strings. All right, compile this now, run this. There you see, Ravi is talking and Ramu is walking. So with this one definition of a class, all right, I have created two objects, and two objects have separate data. P has its own name and P1 has its own name. P is talking and P1 is walking. Sorry about that. So this is what is the benefit of using this object-oriented programming concepts and using the class and object. Now I have two objects in my system. Okay, I have two objects. One object is P, one object is P1. All right. Similarly, in case of this example here, I have a class called account. I have fields like account number, account name, and balance. And then these are the behaviors like set account number, set name, deposit, withdraw, calculate interest, blah blah. You might have some several methods. All right. So now we have this as instance variables, and these are instance methods. So why are they called as instance variables and instance methods? Is that I mean they are part and parcel of every object, and every object has its own data. Every object has its own variables here, and that's where it kind of is important for your classes for your objects, that your object is securing its own data. Your object is having its own data. All right, every object has its own data, and the methods are which are manipulating the same data. All right, so now in these kind of scenarios, you are actually benefiting the use of having this class definition, and you are creating an object, and that's how it works. Okay, so let's move forward in this slide. This keyword is also being referred here. I have this keyword called this in my class. This refers to the current class object, the current object. It refers to the current object. So if I have to implement functionality like maybe set age, we will see this kind of examples in later discussion also, but just to give you some information about what is this keyword, I'm implementing this method void set age. For example, I want to set some age. Okay, so here I'll use this I'll use a variable here, a parameter int age, right? And then I'll say this object age. Okay, this dot age equals to age. It means that this method set age will expect an integer called age from the calling class. All right, so from at this level it should pass this age. All right, and once this age is passed to this method, we will assign that age to this dot age. It means that this current object, this here refers to the current class object. So just like I am doing p dot talk or p dot name here, I am doing it outside the class, but inside the class, if I have to do, I have to do it using this keyword, this keyword. So now let me call this method p dot set age, and here I pass some variable, okay, some value like 23, and maybe if I want to say void get age, for example, if I want to print what the age is, I'll use system.out.println age, or I can say this dot age as well, or it's okay, this dot age. So let me compile this and run this. Okay, I didn't call the age method, I will call it over here. Set age is 23 in p, and now I will say p dot get age. It will say age is 23. All right, 23 is printed. But if I do the same p dot p1 dot get age, because I have not provided any age value for p1 object, it will simply display 0. All right, so I hope you are following this. It's okay even if you get overwhelmed at this. It might be a bit more for you, but it's fine. We will understand it in future discussions as to what it means. All right. So in this is my class account. I have account number, I have string name, double balance, and set account number, and deposit, and so on and so forth. All right, now how do I instantiate the object? So to instantiate an object, as we have seen, we have to use this keyword new. In fact, new it's an operator. Again, it is used to create object, right? So I have to say account AC or whatever. This is the variable, and new object is the object created. Then using that variable, using that object handle, object reference also you can say, using this object reference, you are calling the methods, or you can also refer to the instance variables if the scope is visible. All right. So I'm doing account.set name, set balance, deposit, etc. So declaration is this. Let's talk about this example only. Person P is the declaration, new person is the object which is created. Similarly, person P1 equals to the declaration and new object is the object which is created at the runtime. Now, if you remember, we have spoken about the memory areas in Java. I told you that there are two portions of memory in Java. One is the stack area, one is the heap area. All right. Stack refers to the modular and to the contiguous memory, which is structured. All right. So you have structured memory just like an array of bytes. All right. And heap is unstructured. So on stack you have all the instance variables defined. Int a equals to 10, let's assume. So this is an instance variable which is declared as well as initialized. So that is stored in a stack. Or maybe if you have char c equals to I, let's assume this is one another uh, variable. So these kind of all the primitives which are having defined memory, they are stored in stack. Whereas objects, all right, the objects, like in our example, we have created person P, new person. So in case of objects, only the reference is stored on the stack side. All right, just the reference is stored on the stack P or P1, and the actual object is created on the heap side. And because the objects are dynamically created and the memory is allocated at the runtime dynamically, and even if the object is removed from the application at the runtime, that is garbage collected at the heap area only. So this is how you have to understand what is a stack and what is a heap. Alright. Now the references are stored on the stack, but they are actually referring to the object using some hard references. Alright. They call object based on references. I hope it makes sense. So whenever you are calling something on P object, it actually calls this object. So P has a name, right? What was the name we have given to P object? It was Ravi, and age is 23. So I have said Ravi, and age is 23. And in case of P1, I have given the name as Ramu, and age I haven't given anything, so it is taking by default 0. Unless I initialize or unless I give some value, it takes the default value. As in case of arrays, if you remember that we have created an array yesterday, if we have not initialized any element explicitly, it means it is taking the default value. So here as well, this is the default value for your integer, which is 0. So this is what I mean by saying an object is an instance of a class. So this is one instance, okay? This is one instance, this is another instance. And the reason the instance variables are called as instance variables are the reason is every object has got its own um, data. So P1 has its own data, which is Ravi and 23, and P2 has its own data, Ramu or 0. Well, it was P and P1, not P1, P2. Whatever, you now follow this discussion, I hope. So that's where as I said, that this is the stack area which has the references. This is the heap area which has the actual objects. All right. And after calling the methods like set method and all, it becomes the value. So unless I initialize the values, it is default values, and after initializing, it gets the actual values. All right. So and then as I said a while ago, that objects which are not used at the runtime, or maybe the object if it is unreferenced in the program level, the reference will be removed from the stack. So in case of example, just look at this here. I have two account objects. One is account 1 and the value is 1, account 2 and this value is 2. So in case where I'm pointing to account 1 equals to account 2, I'm doing what? I'm actually referring the account 1 object to account 2 object. Account 1 reference to account 2 object, sorry. So this is account 1 reference, it is referring to the account 2 object. So now both the references are pointing to the same object. It means this object is now unreferenced. So unreferenced objects are kind of lonely objects in the heap area. It means they are lonely, they don't have references to support them, and whenever these kind of objects are available, it is waste of memory in your heap area. And that's where this feature of Java, that is garbage collection, comes very handy. This feature actually checks at regular interval, it checks for unreferenced objects or objects which are not having any reference, and it kind of clears those objects at the runtime. All right. So this happens by Java automatically. We don't have to actually do anything for calling the garbage collection. All right. So when an object is not referred by any variable, Java automatically reclaims memory used by that object. It simply calls the garbage collector. There might be cases where you want to specify that garbage collection should be done explicitly. So in that kind of situations, you specify system.gc, and system.gc is used for specifying that garbage collection can happen here, but it doesn't actually mandate the system to call the garbage collector. There are cases when even if you specify that, the JVM will not call the garbage collector at all. Right? So you have to know this point, that garbage collector runs on Java's priority threads, and whenever it feels that it has to call it, it will call it. So actually it has its own metrics to understand as to when it should call. There are cases like memory should go to a certain extent, and that is when it can check for unused memory as well. All right. So this is something about your uh, object, and how does the object is occupied in the heap area and all. So I'll stop here for a moment and ask for questions if you have any. Do you have any questions to answer?
No, actually, it's kind of scary, so please go ahead.
All right, it was Sampath.
Yeah.
All right. And how about Abhishek? You good? All right. So let me take a break for 10 minutes here. I'll stop this session for 10 minutes and then we will continue with the future topic. Okay.
Yeah, okay, no problem.
Sure then. All right. So let's again connect in 10 minutes from now.
Okay.
Thank you.